Good day, everyone. So our topic is stoichiometry. This is the part two of my discussion for this week. So under this, we are going to discuss mole to mole, mass to mass, and mole to mass or mass to mole stoichiometry. So I am Dr. Erwin Abrencilio. So let us first have our learning outcomes. So first is calculate the mass of a product involved in chemical reaction from a given mass of reactants. So this is the mass to mass relationship. Second is determine the mole of a product involved in a chemical reaction from a given mole of reactants. So this is mole to mole relationship. And the third one is solve the mass of a product involved in a chemical reaction from a given mole and vice versa. So this is mass to mole and mole to mass relationships. So let us first discuss what mole ratio is. It is a conversion factor derived from the coefficients of a balanced chemical equation interpreted in terms of mole. So for you to be able to understand this better, make sure that you are really equipped when it comes with balancing of chemical equation, as well as how to write a complete and balanced chemical equation. So in chemical calculations, mole ratios are used to convert between given number of moles of a reactant or product to moles of a different reactant or product. So simply, it is an analysis of the reactants and products of a certain chemical reaction that is using the chemical equation. So for example, we have here um, the balance equation or the production of ammonia. So for that, we have the reactants of nitrogen gas or N2 and hydrogen gas or H2 forming NH3 or the ammonia. So with that, of course, you have to balance the reactants and the products. So in here, we have on the left side, or in the reactant side, you have there the two atoms of nitrogen and two atoms of hydrogen. Now, you have to write coefficient of 3 in the hydrogen to balance it. Same thing as with the coefficient of 2 to for ammonia. So with that, it is already balanced. Now, since we're talking about the mole ratio and with the given equation, so we have 1 mole of N2 is to 3 mole of H2. So it is likewise based on the given chemical equation. So let me point that out. This is N2. That's 1 mole. And this, if there's no coefficient, it is automatically 1. And then this is 3 mole of H2. So that's our first mole ratio. And then another mole ratio is let me erase that. Another mole ratio is 2 mole of ammonia. So this is 2 mole of ammonia and 1 mole of N2. So that's another. So this is one, that one. So that's another ratio. And then we can, wait, let me erase this. We can identify another, which is 3 mole of H2 and 2 mole of ammonia. So which is this one? All right. So meaning to say that you can be able to identify 3 mole ratios in this given chemical equation. Okay, so let us now move on to the next. Okay, so let us now begin with the mole-to-mole calculation. So in the mole ratio below, W is the unknown or the wanted quantity. and G is the given quantity. The values of A and B are coefficients from the balance equation. So the general solution for a mole-to-mole problem is given by the formula here. No, so you have here the X mole of the given and B mole of the wanted quantity divided by A mole of the given. You'll be able to get XB over A mole of the wanted quantity. Of course, you can better understand this by looking at the given example. So, for example, so how many moles of ammonia are produced when 0.60 mole of nitrogen reacts with hydrogen? So, first is you have to analyze the unknown. You have to list the known and the unknown. So, this is equivalent to writing the given in my previous discussion. So, as well as you have to write first the complete and balanced equation. So based on the given, you can be able to write the balance equation. You cannot start this analysis, including the other relationships, without writing first the balanced chemical reaction. So that's the only time that you can be able to get the ratio. If you fail to write a balance equation, then therefore everything will become a mistake, or you can commit errors in solving your problem. So for the known, we have 0.60 mole of N2 based on the given, and the unknown is the moles of ammonia. So the next thing is you have to solve for the unknown. So write the mole ratio that will allow you to convert from mole of N2 to mole of ammonia. So in that, you can write 2 mole of ammonia and 1 mole of N2 since we are looking for the N2. And then we are looking for the ammonia. The given mole is N2. So multiply the given quantity of N2 by the mole ratio in order to find the moles of ammonia. So in the previous slide, our mole ratio is 2:1, 2 mole of ammonia divided by 1 mole of nitrogen. So our given is 0.60 mole of nitrogen. So of course, you have to write in such a way that the given will be canceled. So the given is a mole of nitrogen. So the denominator should be the mole of nitrogen also. So mole N2 are canceled both for the given and the mole ratio. Then multiply 0.6 times 2, you'll be able to get 1.2 mole of ammonia. So you can likewise double check it by evaluating the answer. So does the result make sense? So the ratio of 1.2 mole of ammonia to 0.60 mole is 2:1, as predicted by the balance equation. So let us now proceed to the mass-to-mass calculation. So in the laboratory, the amount of a substance is usually determined by measuring its mass in grams. It is easier to measure since there are a lot of tools that we can use to measure the mass of a certain sample. So if a given sample is measured in grams, then the mass can be converted to mole by using the molar mass. So I have explained to you in the previous slides how to get the molar mass of an element or how to get the molar mass of a compound. So the mole ratio from the balance equations can be used to calculate the number of moles of the unknown. So if it is the mass of the unknown that needs to be determined, then the number of moles of the unknown can be multiplied by the molar mass. Of course, you can understand this better by analyzing the given samples on the next slides. So the first step is to change the mass of the given to the mole of the given, or mass of the given to mole of the given, by using the molar mass of the given with the given formula of mass G times 1 mole of G divided by molar mass of G is equal to the mole of G. So G is the given. You can likewise change the mole of G to moles of wanted quantity, or W, mole of G to mole of W. So by using the ratio from the balance equation of mole G times B mole W divided by A mole G is equal to mole W. And then the third one is change the mole of W to grams of W. Mole W is equal, produce mass of W by using the molar mass of W. So with a given formula of mole W times molar mass W divided by 1 mole of W is equal to mass of W. Do not be confused with this. So the figure below shows another way to represent the steps for doing mole to mass and mass to mole stoichiometry calculations. So let us proceed to the example so that you can be able to see this better. So calculate the number of grams of ammonia produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. So the balance equation is N2 plus 3H2 produce 2NH3. So we have the same chemical equation from the first computation. So same steps, analyze the unknown and the unknown, the known and the unknown. So in here, since we're talking about the mass, so you have to write there the mass. Mass of the hydrogen from the given is 5.40 gram H2. Then you have there the 3 mole of H2, 2 mole of ammonia, 1 mole of H2, 2 grams of hydrogen, 1 mole of ammonia is equal to 117 gram ammonia. So that this is based on the molar mass. For example, that's why it's 2 grams for H2 because there's 1 gram per mole for hydrogen. So it's automatically 2 grams since there are 2 atoms of hydrogen. That's why it is H2. So same thing as with the computation of the others. Okay, so the unknown is the mass of the ammonia in grams. So again, you have to analyze the known and the unknown. You have to write everything. So the coefficient of the balance equation shows that 3 mole of H2 reacts with 1 mole of N2 to produce 2 mole of ammonia. So with that, you can see here, G of H2 going to mole of H2 to mole of ammonia to gram of ammonia. So from the given quantity, you have here 5.40 gram of H2. So then you have to write the mole ratio. So this is 1 mole of H2 to 2 grams of H2. This one is the molar mass. And then you have the mole ratio, the next one. So 2 is to 3. And then the change moles to grams. This is 17 gram ammonia. So cancel out the units. So at the end of it, you'll be able to get the grams of ammonia, which is the one being looked for in this problem. So with that, you can be able to see that the answer is 31 gram of ammonia. So does the result make sense? So because there are 3 conversion factors involved in this solution, it is more difficult to estimate an answer. So because the molar mass of ammonia is substantially greater than the molar mass of H2, let's put this one first. The answer should have a larger mass than the given mass. So the answer should have 2 significant figures. So in a typical stoichiometric problem, the given quantity is first converted to mole. So then the mole ratio from the balance equation is used to calculate the number of moles of the wanted substance. Finally, the moles are converted to any other unit of measurement related to the unit of mole as the problem requires. So anyway, we can still look into this. The mole mass relationship gives you 2 conversion factors. So 1 over molar mass and molar mass divided by 1 mole. So recall the mole can be related to other quantities. So 1 mole is 6.02 times 10 to the 23rd particles, or 1 mole of a gas is equivalent to 22.4 liter at STP. STP means standard temperature pressure. So this provides 4 more conversion factors. So 1 mole over 6.02 times 10 to the 23rd particles and 6.02 times 10 to the 23rd particles over 1 mole, or 1 mole over 22.4 liter and 22.4 liter over 1 mole. So this is the summary of the stoichiometry problem. So we can likewise calculate the molecules of a product. Then again, you have to write first the balance equation. So how many molecules of oxygen are produced when 29.2 grams of water is decomposed by electrolysis according to this balance equation? So again, you have to write the balance equation. Then you have to write the mole ratio. So write the known and then write the unknown. These are these in the given are the molar mass and as well as the equivalent of 1 mole of oxygen, which is equivalent to Avogadro's number. Then calculate, solve for the unknown. So 29.2 gram of water. So this is the change to mole. So 1 mole of H2O over 18 grams of H2O. And then the mole ratio of 1:2. And then the Avogadro's number of 6.02 times 10 to the 23rd molecules of oxygen. You'll be able to get 4.88 times 10 to the 23rd molecules of oxygen. So again, the last step that you have to do is to evaluate whether the result makes sense. So since you are done with the lecture part, so I'm giving you these activities that you have to answer and to be submitted at the end of the session. So solve the following problems. So you have here 1, 2, and 3. So you are to submit this on our official platform, or you can make this as a practice of your skills in solving. Right? So thank you so much again and have a good day.